algebra. Welcome back to our last video for this week. I'm going to talk to you about the quadratic formula and how to solve a quadratic equation using the quadratic formula. In a normal semester, I would really show you everything about where this came from and we'd have a lot of fun with it. But this is not a normal situation. And so I'm going to try to give you just the bare bones of what I think is the most important. So notice here when we have a quadratic equation written in standard form, any quadratic equation can be solved using this quadratic formula right here. And I'm going to go through and show you how that goes. All right. So we have here a quadratic equation. X squared plus 5x plus 1 equals 0. So far, we know two methods on how to solve it. We could factor it, or we could use the zero product, or we could use the square root property. So the square root property is not going to work because of this term. And we actually cannot factor this. This is not factorable. But the quadratic equation is here, or the quadratic formula is here to save us. So our first thing to check is this in standard form? Ax squared plus bx plus c? And yes, indeed it is. So what is a, b, and c in this case? A is equal to 1, b is equal to 5, and c is equal to 1. So the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I'm going to do, here I have an a is equal to 1. So everywhere that I see a in this equation, I'm going to replace it with the number 1. B here is equal to 5. So everywhere that I see b, I'm going to replace it with 5. And c here is equal to 1. So everywhere that I see, everywhere that I see c is going to be replaced with 1. And then after that, all I do is simplify and we're good to go. So x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 1 all over 2 times 1. And again here, this 1 is coming from A. This 5 is coming from B. This 1 is coming from C. And the rest of these values here and here, these are coming from the formula. So all we have to do now is clean this up a little bit. So this is negative 5 plus or minus 5 squared equals 25 minus 4, all divided by 2. So that's negative 5 plus or minus the square root of 21 all over 2. You do want to check and see, can we simplify this square root at all? 21 is just 3 times 7. So there's no more simplifying we can do. So now this gives us two answers. Negative 5 plus the square root of 21 divided by 2, and negative 5 minus the square root of 21 divided by 2. And those would be our two answers. It's fine with me if you leave your answer like this, negative 5 plus or minus the square root of 21 over 2. That's okay. You could do it either way. Let's do another example. Let's try example 2. We're going to solve 9x squared equals negative 3x plus 2. So the first thing we want to do is put this equation into standard form. So we have 9x squared equals negative 3x plus 2. And to be in standard form, we want all of this to be moved. So let's add 3x to each side. Now I have 9x squared plus 3x is equal to 2. And then subtract 2 from each side. 9x squared plus 3x minus 2 is equal to 0. If you want, you can do these in one step, if you like. I just did it in 2 because I'm a teacher, but you can combine them if you see that. All right. And the next thing would be to notice your A, B, and C. So here A is 9, B is 3, and C is negative 2. So our quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. I'm going to match my color scheme I did before. I think that helps. So we had blue, yellow, and then green. All right. So a is equal to 9. So everywhere I see a in this equation is going to be the number 9. B is equal to 3. So everywhere that I see b in this equation, I'm going to replace it with a 3. And c is equal to negative 2. So I'm going to replace that c with negative 2. So I'm going to replace all of these values and then do some simplifying. So then we get negative b plus or minus the square root. Oops, I didn't put in my blue a. So we get negative 9 plus or minus the square root of 9 squared minus 4 times 9 times negative 2 all over 2 times 9. And now we're just going to simplify this. We get negative 9 plus or minus the square root of 81. Subtract, let's see, 8 times 9 would be 72. So we're going to add 72. That's because I have a negative times a negative, so it's giving me a positive number. All divided by 18. So this gives us negative 9 plus or minus the square root of 153 divided by 18. Again, you want to check and see if we can simplify this any further. So it's not divisible by 2. It is divisible by 3. So that would be 51. And that's also divisible by 3. That would be 17. So we can simplify that square root using our square root product property. See, it's all coming together. Stuff we learned at the beginning of the course. Don't feel bad if you need to go back and review. All right. And now I can simplify a little bit further. By taking out the GCF. And I have negative 3 plus or minus the square root of 17 all over 6. And that would be my final answer. Great. So I do want to point out something to you about the quadratic formula. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This part of the quadratic formula is so important and special that it has a name. So this is called the discriminant. B squared minus 4ac is called the discriminant. So we talked about complex numbers and imaginary numbers here this week. And this is called the discriminant because it's going to help us figure out the different kinds of solutions we can have for our quadratic equation. So let's suppose that b squared minus 4ac is less than 0. Then the discriminant spelling, guys, it's hard, is negative. And if I take the square root of a negative number, I get a complex number. So that's one thing that can happen when I have a quadratic formula. Okay. Another thing that could happen is, suppose b squared minus 4ac is just equal to 0. Well, then my quadratic formula changes. Negative b plus or minus the square root of b squared minus 4ac all over 2a, and I'm saying, what if all this junk becomes 0? And then I'd just be left with negative b plus or minus the square root of 0 all over 2a. It would just be negative b over 2a. And I only get one answer. That could happen. The other situation we could have is b squared minus 4ac could just be bigger than 0. That's like our first example. With two solutions. With two real solutions. Real numbers, not complex numbers. Solutions. So let's do a couple examples. We're going to use the discriminant. To predict what kind of solution we should have. Of these equations here. So we're going to do x squared plus 4x plus 4 equals 0. We're going to do 8x squared plus 14x plus 3 is equal to 0. We're going to do 3x squared minus 5x minus 2 is equal to 0. And we're going to do 3x squared minus 10x plus 15 is equal to 0. And remember, our discriminant is b squared minus 4ac. It's just that tiny piece of the quadratic formula. That's our discriminant. So let's go ahead and go through each one of these and label what is our b. So I see the b term. The negative is included, if you're wondering, when you're looking at these coefficients. You include the sign. So there's our b. Our a here would be 1, 8, 3, and 3. And our c would be the term in green. And all we're looking at is b squared minus 4ac to tell us a little bit more about each of the solution. So for the first one, let's see, I'll work all these in blue. we would have 4 squared minus 4 times 1 times 4. And that equals 0. So for the first one, we would predict one real solution. For the second one, we would have 14 squared minus 4 times 8 times 3. I'll give you a second to work that out. And so this is going to be actually equal to 100. So we would have 2 real solutions. For the third one, our discriminant will be negative 5 squared minus 4 times 3 times negative 2. And that would give us 49. So we get 2 real solutions. And then for our last one, we get negative 10 squared minus 4 times 3 times 15. And that gives us our first negative, negative 80. So when I take the square root of that, I'm going to get complex numbers. So there's going to be 2 complex solutions. So I'm going to go ahead and work through number 4 and show you what it would look like if I did a quadratic equation. If I did the quadratic formula to solve a quadratic equation where I had complex number solutions. So let's go ahead and solve 3x squared minus 10x plus 15 is equal to 0. We're going to use our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in our fourth example, we actually calculated the b squared minus 4ac part already, and we found that was negative 80. But we're going to go ahead and just walk through it and do the whole thing. So here we have a is equal to 3, b is equal to negative 10, and c is equal to 15. So I'm going to substitute that in. So we have negative 10 plus or minus the square root, negative 10 squared minus 4 times 3 times 15 all over 2 times 3. And like before, so we have 10 plus or minus the square root of 100 minus, let's see, 4 times 15 gives me 60. What? Oh, 15. Guys, I'm having trouble multiplying. I'm just going to have to do it the long way. Quarantine. It's getting tired. Times 3. And then we get 5. Carry 1, 3, 4, 45. So that was 3 times 4. And then we get 0. Carry the 2, 16, 17, 18. Okay, that's what I expected. Phew! I was getting it wrong somehow. All right, so 180. Phew! So I have 100 minus 180 divided by 6. So this gives me 10 plus or minus the square root of negative 80 all over 6. And we're going to simplify this square root here. So I'm going to do this off to the side in red. So first thing I want to do is I say negative 80, and I'm going to factor that. I get negative 1 and 80. And then here I might recognize that's the same as 2 and 40, and that would be 2 and 20, 2 and 10, 2 and 5. So I'm taking these out. And then the square root of negative 1 is equal to I. So then what we get here, if I substitute this back in, is 10 plus or minus 4I square root of 5 divided by 6. So the 4 is coming from, I took out 1, 2, and a second 2, and I multiplied those together, and that's where I get this 4, right here. And the I is coming from simplifying the square root of negative 1, which is equal to I. And now I can simplify further. I can take out the GCF from my numerator, and that's 2 times 5 plus or minus 2I root 5 divided by 6. And now I have a common factor of 2 here and here. So I get 5 plus or minus 2 times I square root of 5 divided by 3. And that would be my complex solution for using the quadratic formula. All right, I think the best bet is for you guys to go